Hello and again welcome to our channel Bit Astro. So here I am Suraj with a new video of mine on the topic vector spaces, that what exactly the vector spaces is. So this is our new mathematical physics topic. In my previous videos I had taught you about the Fourier series, about the partial differentiation, about the vector operators and a bit of quantum mechanics. But to understand the real quantum mechanics or the advanced physics, you have a very great knowledge or a deep knowledge of the mathematics. That's why I am doing this mathematical series. So our third series is the vector space, that what exactly the vector space is and how can we relate it with that what we study vectors in class 11th. What's the relationship between this? So everyone knows what vector is, you know what's a vector is. This is a very basic thing. Vector is any type of the physical quantity which contains the both magnitude and the direction. So this is a very basic thing. Okay, so our topic is not to understand what's vector is. Okay, so generally our topic is to understand the vector spaces. So suppose that how can you describe a vector in a three dimension? Yeah, you can describe a vector in a three dimension. How? So you can describe a v vector in a three dimension as its x component and in y component and in z and I cap, j cap plus v z k cap. So here I can represent a v vector. I can represent a v vector in terms of the component like this, where Vx is the x component, y component and the z component of the V respectively in the x, y, z coordinates. And I cap, j cap, k cap are the directions vectors, which tells us not known as unit vectors. That tells us the direction of our vectors, in which direction it is, and they are perpendicular to each other, or in a advanced sense they are orthonormal with each other. Okay, so what is vector spaces now? Okay, so this is the basic meaning of vectors. How can we represent vector in three dimension by these types of the vectors known as the unit vectors. Okay, what is vector spaces? So generally vector spaces is the collection of the vectors, collection of vectors A, maybe B, C, D, any vectors in an n dimension. In an n dimension, this is the collections of vectors is what known as vector space in an n dimension. N means any 1, 2 dimension, 3 dimension, 4 dimension, like this v vector is a three-dimensional vector. Okay, so it has a three components, vx, vy, vz, and represented by the unit vectors. So vector spaces is an space that we imagine where there is a collections of the different types of the vectors, collection of the different types of the vectors, in which the dimension is not restricted to 3. In this case, what you study in class 11th and 12th, the highest dimensions that you study in vectors is the 3 dimension. Okay, so maybe 3 dimension is also not there, but regularly we study the 3 dimensions vector. But what happens if there is an n-dimensional vector? That's why vector spaces is an advanced topic where we deals with the vectors in an n dimension. It means the dimension is not fixed. Maybe n can be any number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and whatever this is. Okay, so it's a collections of the vectors A, B, C, and respectively. So vector spaces is the collection of vectors, you understand. Okay, so if there is a collection of vectors, there may be a vectors like I cap, j cap, and here k cap, which is used to represent our data. What I'm trying to say that कि जैसे इस particular v vector को ये i cap, j cap, k cap डायरेक्शन उसका बता रहे हैं कि ये उस पर्टिकुलर डायरेक्शन में वेक्टर का ये कॉम्पोनेंट है उस पर्टिकुलर डायरेक्शन में. इट मीन्स कि वेक्टर स्पेसेस में भी होगा कोई तरीका. वेक्टर स्पेसेस में भी हम लोग कोई हमारे पास एक ऐसा यूनिट वेक्टर्स होगा, तो या बेसिस वेक्टर्स उसी को कहा जाता है. तो यूनिट वेक्टर्स का ही दूसरा नाम है बेसिस वेक्टर्स, and it is also a very important topic in the vector spaces. Okay, so basis vectors. What? Basis vectors. So this is a very important topic, you know. So basis vectors. What is the basis vectors? So basis vectors, just like I cap and j cap, gives the direction of the vector. Just like in an n-dimensional vector spaces, there is a basis vectors called ei, which represents the component, which represents that in which direction a particular vector is, in which direction a particular vector is. That's the meaning of the basis vector. So basis vectors and unit vectors are the same thing. Basis vectors is equals to the unit vectors. Okay, so just like there in the vector spaces, there is a basis vector which denotes that in which direction there is a particular vector and which direction it exists. Okay, so how can we represent a vector in an n-dimensional vector spaces with its component? So x, suppose that is x component, x vector, suppose that, so x vector in an n-dimensional vector spaces can be represented as the summation of n is equals to the 1, it's n. Okay, so n is equals to the, maybe you can say that I. Okay, so I is equals to the 1 to n of e I x I. So this is a representation of vectors in a basis, in a vector spaces. Okay, so यहाँ पे क्या हो रहा है कि एक पर्टिकुलर वेक्टर को हम लोग कैसे रिप्रेजेंट कर सकते हैं n डायमेंशन में, तो ऐसे रिप्रेजेंट कर सकते हैं. In n dimension, we represents our vectors like this. So if the dimension is 5, we have to do what? If the dimension is 5, what we have to do? So if the dimension is 5, our data will give is e1 x1, okay, plus e2 x2 plus e3 x3, and so on till 5. Okay, so if there is a 5-dimensional vector, this is 5-dimensional vector spaces. But there is a, it's very useful things that how we can define the vectors in an n dimension. Okay, so we can define the vectors in an n dimension. Now move towards the some of the applications of the basis vectors, that what are the applications of the basis vectors, and what the some of the very important properties of the vector basis vectors in the vector spaces. So उससे पहले एक चीज़ मैं आपको डिस्कस करना चाहूँगा जिससे आप डिस्कस कर ये रिलेट कर पाएंगे यूनिट वेक्टर्स को और बेसिस वेक्टर्स को. तो सब हमने बहुत अच्छे से पढ़ा है कि आई कैप और जे कैप दोनों का डॉट प्रोडक्ट क्या होता है. डॉट प्रोडक्ट मीन्स द स्केलर प्रोडक्ट. सो हाउ वी कैन डिफाइन द स्केलर प्रोडक्ट ऑफ दिस पर्टिकुलर टू फंक्शन, दिस पर्टिकुलर टू वेक्टर्स. So we can, so what's this is, it's equals to the 0 or whatever. So the I cap dot j cap is equals to the 0. It means I cap and j cap is equals to the 0. But what is when we do the dot product of the I cap and I cap? Then it is equals to the 1. Equals to the 1. Yes. So just like this, in vector spaces, ei is there, and suppose that ej is there. Okay, this is the notation of the sign of the, just like dot, we can define the dot product in the vectors like this, but in n dimension vector spaces we define the dot product like this. This is known as bracket notation, Dirac notations maybe, but this is very high advanced. So for you, let's understand this. This is the only thing that means we are doing the dot product of these two vectors. So when we do the dot product of these two particular vectors, it is equals to the canonical delta. Canonical delta means nothing. If m is equals to the n, just like in this case, it means if I is equals to the j, its value is equals to the 1. And if m is not equal to n, then its value is equals to the 0. Just like in this case, I cap and j cap are not equal. So it means m is not equals to n, it means these are not equal and its dot product is 0. But I cap into I cap dot product is equals to the 1. It means I cap into the j cap dot product, if m is equals to the n, it means if I is equals to the j is equals to the 1. Because in vector spaces, if there is a two-dimension vector spaces, and if there is an ei and there is an ej, they both are always orthonormal or 90-degree with each other. 90-degree with each other. So this is a property of a vector spaces. This is a property of a vector spaces, and this is how we can represent our vector in an n dimension. But this is a very no sloppy thing. To define exactly the vector, how we can do like this, that to represent the x vector in an n dimension can be represented as n is equals to, sorry, in an n dimension can be written as I is equals to the 1 to the n uh, dot product of xi ei. Okay, so this is nothing, this is just the advanced version of this. This is the not a very advanced version, but a more powerful tool is this defines the dot product of the two vectors. This defines the dot product of the two vectors. And exactly how you can describe, the xi vector, you can describe this particular xi vector as I is equals to the 1 to the n as the ei into the x vector. Okay, so how you can relate this thing? So relate this particular thing like the thing that how you represent a velocity vector. So velocity vector can be represented as vx I cap in a two dimension, I am saying, plus vz vy j cap. Okay, so this is how a velocity vector in a two dimension represents. So just like this, in this case, if you have seen that this is the component of the vector and there is a dot product of this component and the I cap. Just like this, we define the x vector like the dot product of its component into the e I, where e is the basis vectors. It means e is working like I cap in this case. E is working like I cap, just like I cap. Remember, basis vectors and unit vectors are not different. I have just only changed the I to the E because there is an n dimension of vector spaces, not a fixed dimension vector spaces, and that's how we describe this particular thing. So what we have done is that we described that what is vector spaces, how can we represent a vector in an n dimensional vector spaces, what's the notation of the inner product. Okay, what's the notation of the scalar product? This is equivalent to the scalar product in the two or three dimension. Okay, but this has very advanced name. Okay, this has very advanced name, and this is what known as, I have written here, that the thing ei into the ej, which is generally it equals to the canonical delta, where the canonical delta, if m is equals to the n, is equals to the 1, and if m is not equals to the n, it is equals to the 0. So just like the scalar product in the vector in 1 and 2 three-dimensional vector, in an n-dimensional vector the scalar product is known as the inner product. Inner product. Okay, this is known as the inner product in the n-dimensional vector spaces, and there is some properties of the inner product which I am going to discuss. Remember, inner product is just same as the scalar product, but inner product is in the n-dimensional vector spaces. Okay, in an n-dimensional vector spaces. So there is some of the properties in the inner product which I will discuss here. That suppose that there is a vector A. Assume that there is a vector A and vector V in an n-dimensional vector space. So what's the inner product of A and B? So inner product of A and B is not same as A dot B. It is not same as this. It means, sorry, this is not same as BA. Because we are dealing with a vector spaces, there are some of the complex quantities also involved. So the involvement of the complex quantities, we can say that when you do the inner product of the two vectors in an n-dimensional vector spaces, it is equals to the, again doing the inner product and the complex, doing the complex conjugate of this particular thing. What is complex conjugate? Complex conjugate is nothing. Suppose that there is an imaginary part iota. ठीक है, suppose that you imagine a z function which is equals to the x plus iota b. So the complex conjugate of z means nothing. The complex conjugate z means by just replacing the sign here. Complex conjugate has a sign like this. So complex conjugate is equals to just nothing. Converted the plus into minus where there is an iota term. So complex conjugate is nothing. But when we are dealing with an n-dimensional vector spaces, complex conjugate plays a very important role. That's in these cases, these two are equal. But how they are equal? I know that these topics may feel a very advanced topic. No, these topics require some of the very high level knowledge. So all the things that I have written, I will give you the proof of all that things, because what's the proof that these things are equal? So in this video, we have discussed about what's the vector spaces is, what is basis vectors, basis and unit vectors are equal, then dot products, how we can define the inner product of the two basis vectors, how we can define the inner product, some properties of the inner product. But this is a very abstract topic, so it requires a very long series of videos so that you can understand it. So in the next video, I came with more advanced or good explanations to this topic with various types of the examples, and also some of the important topics in this, and doing questions also is very important. Okay, so in the next video we'll meet and discuss the advanced topics and a very clear explanations with the help of the examples in the vector spaces. So thank you for watching my video.